So, in this video, I'm going to be going over AC, as you can clearly see in this label here. I'm going to be talking about AC and I'm going to be talking about just waveforms in general as well. So, yeah, okay. So, to start off, right, I'm actually going to be talking about AC and DC. So, AC is alternating current, DC is direct current. Okay, so what's the difference? So let's look here. These two graphs is voltage for the y-axis, time for the x-axis. For this the graph on the left here, you can see that the voltage is like kind of goofy, but it's never negative. You see that? It's never negative. On the right, the voltage is positive here. Suddenly it's negative. Suddenly it's positive. Suddenly it's negative again, and then it just does some weird ass shit. So the graph on the left actually shows a DC signal, and the one on the right shows an AC signal. So the definition of what an AC signal is an AC signal is basically a signal that goes from positive voltage to negative voltage periodically, basically, yeah. And for DC, it just never goes negative ever lah. So that's the difference between AC and DC and the definition of AC and DC. Yeah. So for AC, right, there's like a pattern of sometimes positive, sometimes negative, and that's known as a waveform. So there are many kinds of waveforms, but in the syllabus, our O-level syllabus, we need to know four, but mainly three, and it's these few. So here we got the sinusoidal sinusoidal waveform, and you can see it's kind of like S. I don't know, it's like kind of a sideways S. I don't know. Yep. Here we got the square wave or the rectangular waveform. So you can see it looks like a rectangle, and this is the triangular waveform. You can see it's like a triangle. Yeah. Specifically for this square-ish waveform, rectangular waveform, to differentiate whether it's a square or rectangular, you can see like in this one, like this and this are kind of the same, so it kind of looks like a square, therefore it is a square wave. And for this, it's obviously not a square, so it has to be a rectangular waveform. So that's the few types of waveforms. Okay, for all these waveforms, right, there are some properties. So now I'm going to talk about the properties. So here we can see a sine wave, a sinusoidal waveform, and we can actually determine some properties about this. So from this point to this point, it's actually known as the period. So it's going up, it's going down, it's going up, and then it reaches that point again. So basically that point and that point, the movement is like kind of, what am I saying, bro? So a period is from one pattern to the start of one pattern to the start of the next pattern. That and then that duration is known as period. So it is a duration lah. That's how long it takes for it to complete one pattern. That's a period. What am I saying, bruh? Alright, next. Next we got okay, the peak voltage. So up here, this is the peak voltage. This from highest to lowest is the peak to peak voltage. And then DC level is basically where the voltage at which the waveform is oscillating around. So it starts the pattern here and it ends the pattern here. So that's the DC level. Also, one thing is every AC waveform has something known as a frequency. And to find the frequency of a waveform, you can actually do so with this equation. So frequency is equals to 1 divided by the period. Yeah, and it's in hertz. So an example frequency would be like 69 hertz, like that. So yeah, that's how to get the properties of a wave. So let's do an example. So I have this waveform here. If this is not clear, this is 16. So you can pause the video now to try and find out what the DC level is, what the period is, what the peak-to-peak voltage is, what the peak voltage is. So you can pause now to try and find that out. Alright, so let's start with the DC level. I think that's the easiest. DC level is obviously like 6 volts because, again, it starts the pattern here, it ends the pattern here, and this is literally just oscillating around 6 volts. So the DC level has to be 6 volts. Um, peak voltage is this, right? So 16 minus 6, we get 10. So the peak voltage is 10 volts. Peak to peak voltage is from here to below here, so it'll be 16 minus 4, which is actually 20. So peak to peak voltage is 20, and now the frequency is 1 divided by the period. The period it starts here, ends here. You have fallen for my trap. So this question is actually not possible because it says, okay, who am I kidding? Okay, let's just change this to here. Yep, there we go. So 2 seconds is actually here. Anyway, so the period is 2 seconds because it takes 2 seconds for it to complete one pattern. So the frequency would therefore be 1 divided by 2 seconds. So it will be 0.5 hertz. Yeah, so that's that. Next, we can move on to duty cycle. Okay, so we have a rectangular waveform here, and we can see this is the positive bit, right, of this waveform. We're going to name it T high. The negative bit, or the not high bit, is just T low. T referring to time lah. So this is like how long is it positive or high voltage, or how long is it low voltage. So duty cycle, right, we're just saying at what percentage is the waveform on in one period. So we can find it here. It would be T high divided by the period times 100, and then we get a certain percentage. So an example duty cycle would be 69%. Yeah. So I got two examples here. You can pause the video now to find the duty cycle for both of these. Alright, so for this one, again, the duty cycle would be T on divided by the period times 100. And in this case, T on is this here, this green bit. So from here to here is 4 seconds. From here to here is also 4 seconds. So T on is 4 seconds. And the period here to here is 1. And this is one pattern. So the period will be 5 seconds. Then we just times 100. So this would let us get 80. So the duty cycle is 80% for this one. Alright, let's move on. So this one, it may seem a bit harder, but it ain't. Alright, so let's write the thing again. T on divided by period times 100 will be the duty cycle. So now we need to find T on actually. And T on, T high, my bad, T high, it's T high. This should be high. I'm kind of low today, so. Alright, this bit, I'm lagging. I'm lagging in a Discord activity. Alright, this bit where the waveform actually peaks through to the positive voltage, this is T high. This is T high. So T high, actually, this is 1 second. From here to here is 1 second as well. So T high is 1. And then the period. So this is one complete pattern, and this is another complete pattern. So from here to here will be one complete pattern, so 7 seconds. Then we times 100, and that will give us around 14.285-ish%. Yeah. So if you got these two values, you're damn amazing. Alright, so this is AC, and a bit on waveforms and DC and stuff like that. Yeah. So thanks for watching.